Underground mining is an essential part of our economy and provides us with minerals and ores we use every day. Salt, gypsum, trona, and potash are used as fertilizers, glass, soap, water treatment, ceramics, and many other chemical compounds. By far the largest segment of mine material is coal. Coal is located worldwide. It can be found on every continent in over 70 countries, with the biggest reserves in the USA, China, Russia, and India. Coal is used in over 40,000 products, from perfume to golf balls to baking powder. Almost 70% of total global steel production is dependent on coal. Our modern way of life is not possible without electricity. Over half of the electricity in the world is generated from coal. It is the most affordable source of power generation. Prior to the Industrial Revolution, coal mining was dangerous, back-breaking work. In those days, underground mining was limited to picks and shovels, with productivity dependent upon hard-working men laboring in extremely harsh conditions, resulting in only several tons of coal in an entire day. That all changed in 1919. The success of Joe Joy's mechanized loading machine altered the course of underground mining forever. Since then, the company he founded, Joy Mining Machinery, has been at the forefront of underground mining technology. As a result of continued advances in product design with Joy's zero-harm mentality, today's mining industry provides a much safer work environment and is highly productive. There are two approaches for removing materials underground: room and pillar and longwall mining. Room and pillar is a mining method involving the extraction of coal that forms a series of rooms while leaving pillars or columns of coal to help support the mine roof. The rooms are generally 20 to 30 feet wide, and the remaining pillars are 20 to 90 feet wide. As production advances, a grid-like pattern develops. All of the cutting and loading is done with a continuous mining machine. The world's first continuous miner was the Joy 3JCM, which shipped in 1948. This revolutionary machine increased safety by eliminating the use of explosives underground. Productivity increased dramatically, as this one mining machine could do the work of 3 traditional mining methods simultaneously. That tradition of safety and innovation continues today. Joy's modern continuous miners are very advanced pieces of machinery. Cutter heads that use a fine spray of water to reduce dust and friction. Remote control operation, which allows the operator to maintain a safer distance from the equipment. Noise-reducing conveyor systems. Onboard computers that monitor all of the miner's functions. These machines are truly state-of-the-art. The mine material is gathered and moved using one of 2 methods, either by batch haulage or by a continuous haulage system. In batch haulage, a battery hauler or shuttle car collects the mine material from the continuous miner. It is then transported to the mine's feeder breaker that sizes the material and feeds it to a conveyor system, which takes it out of the mine. The first rubber-tired shuttle car was built by Joy in 1938. Since then, more than 17,000 Joy shuttle cars have shipped to mines around the world. Batch haulage systems can cause delays as productivity stops while the cars place change or alternate in and out to pick up a load of material. The goal of continuous mining is to maintain an uninterrupted flow of mine materials to the mine's conveyor. An alternative to batch haulage is implementation of a continuous haulage system like the FCT or a chain haulage system. Flexible conveyor trains, or FCTs, are flexible and have the advantage of being able to snake through the mine's entries. This single operator system follows the miner, transporting material to the conveyor. It is equipped with a memory system to help move in and out of mined entries. The front end has a material sizing and metering function that not only controls the flow of material, but also eliminates the need for a separate feeder breaker. A continuous chain haulage system is a multi-operator rigid system that utilizes a chain drive to transport material out to the conveyor. As mining advances, the roof must be supported. At no point in the mining cycle can a person be under an unsupported roof. These areas are marked in red. Stabilizing the ceiling is the job of the roof bolter. This machine temporarily supports the ceiling as it drills bolts through the stronger rock above to prevent the roof from falling. In addition to the room and pillar mining method is longwall mining. Longwall mining recovers the most material in the least amount of time. First, entry development equipment prepares the way for the longwall mining system by developing a panel or block of coal. The panel is much larger than room and pillar mining. Continuing with its history of innovation, Joy has engineered a specialized system that mines the entry and supports the roof and walls from one machine. This not only reduces the work of two machines to one, but the result is safer mining conditions and faster panel development. After the entries are cut to develop the large panel, the longwall mining system takes over. The main components of a longwall system include a shearer, armored face conveyor, and roof supports. A shearer uses two independently controlled arms with carbide-tipped drums to cut material from the side of the panel or face. An onboard computer allows the operator to set cutting patterns to keep the shear cutting in line with the coal seam. As the shear moves along the panel face, the coal it cuts drops onto the armored face conveyor. The AFC then carries the coal out and deposits it onto the main conveyor belt. After the shearer passes, it communicates electronically to the roof supports. The supports hydraulically pull themselves forward, then set or wedge themselves into place, pushing the conveyor forward. Each roof support exerts enough force to hold more than 16 Abrams tanks. At the end of the panel, the shearer begins a new cut in the opposite direction. As the longwall system advances, the roof is allowed to collapse behind it. The collapsed material is called GOB or GOF. Because this system is synchronous and roof bolting is not needed, there are virtually no delays in production. A longwall system can produce more than 6 times the material than continuous mining. A single day's output of coal can power a 100-watt light bulb continuously for more than 380 years. Mine operations have become much safer, not only due to advances in equipment, but in state-of-the-art control and automation systems. These systems allow the operators to maintain a safer distance from the machinery and coal face. Remote monitoring allows real-time diagnostics to the operator or to a dedicated service center across the world. Demand for electricity continues to rise, and no other fuel is as plentiful or as cost-effective for the generation of electrical power as coal. In 1 minute, a longwall system can provide enough coal to generate the energy required by more than 4 U.S. homes for a year. In 2 8-hour shifts, it can produce enough coal to power the entire country of Haiti for a year. Joy Mining Machinery manufactures a variety of equipment and systems, making it possible for the mining industry to safely cut, haul, and convey thousands of tons of materials per day, keeping up with our increasing demands in the most cost-effective way. For more detailed information about Joy Mining Machinery, visit our website, www.joy.com.